Now I'm going to show you how to check for a slow crank or a no crank, and that's before you remove any of these parts. Your relay's going to be in. We should never see any voltage here while it's cranking. Today we're working on a slow crank or a no crank situation. I'm James Noble. Let's get started. If we've got a slow or a no crank, first thing we're going to check is our battery. And we're going to hook our voltmeter up. We're going to put it on a 20 volt scale, 12.5 volts. Thing's good, charged up. You won't know until you go to crank it to see how much voltage your battery actually does supply out. This is going to tell us whether the volts has not got a good connection. Now this is testing the reserve capability of our battery. If it drops below 9 volts, we know we've got an issue. But we do want to check our bolts, make sure that they're clean. If they're okay, then you're going to need a battery. So let's try cranking. Now since this truck doesn't have an issue with it, it didn't lose, the battery voltage didn't drop down. Now when you're selecting the battery, you want to make sure you get the one that it's recommended for the vehicle, because if not, you may end up with a check engine light and it may still be hard to start. Now if you find it hard to jump it off at the battery bolts, then we'll just move our ground cable from our jumper to the engine block. We'll try it again. If it's still hard to start, then we'll move our positive to our cable block and try it again. This will eliminate the cables. This battery has a 550 pole cranking amp. And once it's started, if you look now, we're pushing 14.5 volts. So that means our charging system's working. So what have we done? We've checked both things at one time. That means that it had enough to start it. Once it started, it's putting voltage back into it, so the entire system voltage. The thing is if you suspect a bad alternator, if your battery is down, your lights dim or anything like that, let this run a while and see if it changes, because sometimes the windings and your components inside your alternator, once they heat up, it'll go down. Now, needless to say, when you're checking your alternator, if your battery voltage drops down below 13.5 volts, you may have an issue. But as this battery charges up, the need of the alternator to keep up a higher voltage drops, so it compensates and it drops as well. So lower voltage here as it gets hotter and has been running, that doesn't show an issue with your alternator. It shows that the battery is starting to charge up. Now, since a typical battery usually goes around 12.5 volts, somewhere in that range, you're not sticking to just 12.5. Now a normal battery has 12.5 volts, somewhere in that area. It may be 12.2 to 12.8. It's usually not below, or usually not above 13 volts. If it is, it's a surface charge. But normally, as the battery charges, the alternator detects that and starts dropping the voltage because it's unnecessary. Now, anytime you get below your normal battery voltage, then you're showing an issue here. Now, if you start this up and you had to jump it off, and it doesn't take long for this alternator to drop back to, say, 13 volts, yet it's still hard to start, most of the time it's the battery. The battery's bad, and once the alternator detects that it doesn't need any more voltage, it starts winding back its output. Another issue, if you got a high resistance somewhere, it'll actually, as it heats up, the resistance will go higher and your voltage will drop down. Next, what we're going to do is we're going to check voltage drop, see what's the difference between the two areas. Now this shows us that our battery bolts has a good connection to our battery. Let's check and see if we got a high resistance in our ground circuit. Now when we're testing resistance, we always want to make sure all our leads, so we know our meter with all our breaks in the connections, is 0.4 ohms. Now with our meter set up, we're going to go from the ground battery post of the bolt, and then we're going to find us a good engine ground. We're still getting 0.4, so that tells us that we've got no resistance in our ground circuit. Now our problem with that is we're not showing any resistance, but we're not under a load, we're not pulling any current through there. And you can't check resistance while you're cranking, so we'll have to do a voltage drop test. Now while we still got our meter hooked up, we're not going to change anything, but we're going to change our scale from resistance to a 20 volt scale. Now when we attempt to crank it, now by doing this, you will see some voltage drop, but it'll probably be 0.1, 0.2. If you get anything higher than that, when you get into voltage, like 1 or 2 volts, then you found your issue, and it's going to be a problem between your battery ground and your engine ground. So you'll want to check them two places. If you see any voltage, say you say 2 volts, see 2 volts, 5 volts, 12 volts, that's a voltage drop of how much voltage you're losing at some ground point, whether it's at your battery, at your engine, at your starter. The starter is grounded through the body of the starter, and where it's mounted to the engine block, that's how it gets its ground. It doesn't have a ground wire actually going to it. Some vehicles will have one near it, but are on the bolt, but the body of the starter is actually what does the grounding. Now your most common area, and most likely you're going to find it, it's going to be where your battery cable is clamped to your battery, or you're going to find corrosion. So first just take and pull on it, and you'll see it's loose. Then you know you found your issue. Now it may be the battery itself that's broke loose on the inside. Either way, that's your issue. Now see, because that cable's loose, I have got 10.28 volts dropped. That means that's of whatever the voltage is of the battery. Let's look and see what the voltage actually is of the battery. Now see, we've got 12 volts. This minus is because I got the wires hooked up backwards. Or we've got the battery showing it's got 12 volts in it. Yet only 9 volts, 10 volts of that 12 volts. So we've lost 9 volts. So really, if I go to start it now, it shouldn't start and probably won't even turn on lights. So this may even go to 12. Now you notice, and that's because I got the battery disconnected. And the point I'm making here is, if your cable is corroded, this will show up right here. And it's the same thing on this other end. If we go from our positive to this, if the cable's corroded, if there's an issue between here and there, it'll show up. So let's do that next. Now we can remove our electrical center cover, or our battery cable going into the fuse center. And we want to get rid of this cover too, so we're going to get rid of these 4 bolts. Got 2 under here, 2 here. We're going to lift out on the bottom of these, 1 on each side, and that's going to release this so we can lift this out. Now here's a look underneath our cover, and this is our battery post that's coming up that's powering this whole block. Now on our positive side, we're going to do the same thing. We're going to hook to our positive bolt on our battery, and then we're going to hook to the bolt that actually runs where the cable runs from the battery into our junction block. In this illustration, I've loosened the positive battery bolt up. That's going to mean the same things if it's got heavy corrosion or if there's an issue with our cable. And this is what you're going to actually see. If you noticed, it went to crank, it opened up, and we went to 12 volts drop. And most of the time what you can do, wiggle our cable, it'll come back. Now if I go to start it again, that's going to go, and you'll notice your headlights is going to flash on for a second, and then they'll shut off. If you've got your ignition switch on, you wiggle, do a wiggle test. Look at there, everything come back on. Now what that's done is it's proven that this cable is, the connection between here and the cable is bad. Now if you've got corrosion built up here, you'll want to go here. If you lose it, you want to make sure that you hadn't got a voltage drop there. Then you'll want to go to the actual bus that's going through there, bus bar. You'll do the same thing again if you don't have a voltage drop. If you don't have a voltage drop, then you're going to go to here and see if you've got a voltage drop. And if you've got a voltage drop here, most likely it's going to be in this section here. Take that bolt loose, clean it real good, tighten it back down, and you should be back up and running. Because most likely it's not in between here, these 2 points. It can be, and if it is, you're going to have a new one of these. And now to our junction block. Now that's everything that we can check for a voltage drop on our positive side. But if you go these steps on the voltage drop, that'll pinpoint exactly where it's at. Now because I have the cable loose, if it had heavy corrosion, you might see 2 or 3 volt drop. And you think about it, when the engine's cranking, the battery voltage comes down because it's using the current, and it'll come down sometimes as low as 9.8 volts, 9.5 volts. If you got a 3 volt drop, that's going to make it 6.5 volts, which is going to make it crank slow. Now this may give you a condition of a slow or a bad starter where it's cranking real slow, but it finally starts. And it'll also give you the same thing in the opposite direction with your alternator. It's not going to allow the voltage to come back to your battery to charge it up, so you may be jumping it off and getting that extra little hump, but in reality it's just where we've got bad corrosion at our battery. What you're going to do here is you're going to go ahead and remove the battery bolt. Now if we look inside, we'll notice that we do have some corrosion. This one wouldn't have any issues, but if yours does, you can take and remove this bolt. Now you can get in behind this insulator and pop your bolt out. Now you can take your wire brush and clean that up. You can go inside here on the battery, your bolt as well. Now we take and put our cover back on and then work our bolt back in to the insulator. Now most of the time what happens here is somebody's either over tightened the bolt or just over time the vibration is broke the inside of where the plastic meets the battery terminal, and it's turned just a little bit and it'll start seeping acid. Okay, I think it's going to do it for this video. If it helped you out, help me out and hit like and subscribe. I appreciate you watching. I'll see you in the next one.